used any proprietary software, so we just use AutoCAD to see how far the locations between the most concentrated points on the event actually itself are. And we looked how are the walls, windows, and so on, the stuff which can do a lot of interferences and reflections. So we make the focus that year on the lecture rooms. Actually, if you're in the building and you're in the ring or something, you can just pull a cable and start to downloading. There's always a switch near behind and you have always parts left. So it was important that the wireless was working in the lecture rooms. For a better performance, we just decided that year to make a better separation of the networks. So this means basically that we structured the networks in VLANs for every SSID here is broadcasted. So we done a separation between 802.11a and b, and also the fixed IP networks. So that are specific VLANs, but on all VLANs are quality of service rules deployed. So quality of service for us means you have at least DHCP, then you got SSH and HTTP, and the stuff for reading mail, POP3 and IMAP. So we does that, and we focused also on peer-to-peer users. So what we're going to do with them, always are people complaining about peer-to-peer users which using BitTorrent, eDonkey, MLDonkey, and so on. And we decided to use therefore a new technique. We deployed a snort box. And this snort box is actually not doing any kind of security or whatever, IDS, IPS. It's doing actually only monitoring pattern matching against eDonkey and BitTorrent stuff. So we deployed the snort box in a separate VLAN and monitored the whole wireless LAN traffic inside of that VLAN. So the snort box were getting an encapsulated GRE tunnel for the whole traffic and all uplink VLANs. Performance without of security is nothing. Today we are seeing that many people are publishing stuff for driver exploitation. This stuff is not new. Drivers have since many years bugs, and especially drivers which are working with dynamic protocols. And if you have a protocol at 802.11, trust me, it's not possible to get it very stable or just secure, because the protocol itself makes it not possible. It's a non-authenticated layer 2 protocol. How you want to secure something like that? So we done for preparation fuzzing of all necessary services on the controller. For us means we done fuzzing on services like ESA-KMP, IPsec, but also on the 802.11 layer. And that helped us to see if there are problems. We found nothing. Especially we found nothing on 802.11. But on IPsec we decided that we're not providing the service because the CPU load was too high. So to look what is coming with CPU load, what the CPU load will be if many users are on it, we do a load test with iPerf. And yeah, at the end, without filtering an access list, you're nothing. So that is also important, especially on your uplink ports and your management ports. So this is actually the topology of the whole network. It's a layer 2 backbone where I connected the Aruba 800 distribution switches over GigE uplinks and trunks for access point management and switch management. Access point management means the controller is only forwarding packets, and the access points are only dump access points which are creating a GRE tunnel from the access point interface for wireless to the controller. The access point is not just a bridge, it's transporting the traffic like is it with the radio tab header with all the 802.11 element IDs to the controller, then de-encapsulate it and process it. For uplink VLANs, like I told you, we used free VLANs, and the snort is also collected directly, gets the traffic over GRE. The access points this year were AP60, AP70, dual mode access point, so we had complete coverage on A, B, G. And that's how it looked like in the air. To get it actually look like that, you have to calibrate it once. I will describe what calibration means, but we had interferences because there are more than 200 people using it, and if you cannot limit the transmit power of a client, you cannot do anything about it. So if you calibrated your system, if you have lowered down the transmit power of your system, there are always clients who have cards with 100 milliwatt of transmit power, and you can do nothing about that. So what does calibration mean? Calibration means all access points are shut down and working in monitor mode for just the time where the calibration is finished. Monitor mode means you're monitoring the 802.11 layer, so the wireless link layer, and it does one station in access point mode. So it sends frames, hello, I'm here, and all other stations looking for the beacon frames from the station who's sending. Every station which these beacon frames will receive will lower down the transmit power so long there are no stations are seen anymore. This first station, which is broadcasting actually. So this is done with 34 access points. It takes about 20 minutes, and then it's finished. We're doing load balancing because most of the rooms had 200, 300 people sitting on one access point. And therefore, we just set a maximum limit on 60 users per access point. So if one access point is full, the users go to the next. The Aruba station is sending a de-authentication package, so it disconnects the user. If the user comes again, it reconnects him. This is only done if the station is not finding any other access point which is better than that one which is already full. And again, traffic shaping is done on that limit also. What we done about security? On 802.11 you have a lot of things to do, and basically it starts with layer 2 frame monitoring. Like I described it, 802.11 is an authenticated management protocol, and the frames are completely spoofable. You can do whatever you want. And we wanted also to see what is coming on us on this event. On DEF CON and other events were things published with driver exploitation stuff. And we were looking after the attacks were here actually starting. We found one interesting attack. So people are sending de-authentication packages, spoof de-authentication packages to us to broadcast address, so to every user. And inside of the de-authentication package you have a 2-byte field for a reason code. This reason code actually means I've disconnected you because your key was wrong, or because you're sending wrong capabilities, you cannot join me because you're not an 802.11g user, only a B user. And this means 2 bytes, 65K of possibilities, and he counted that high. And most of the notebooks which are running Centrino Windows are crashing at that moment. We're doing the same, but we're doing it for protection. We're protecting our users to join rogue access points. So we don't want that you're joining a fake access point and all your SSH fingerprints are other and people are doing man-in-the-middle stuff. And we're of course doing gateway protection, because if someone takes the MAC address of your default gateway and does up-spoofing, whatever, so we blacklist his MAC address and he will be kicked out. So monitoring for troubleshooting. I need a web browser for that. If you have more than 1,000 clients in your network, you want to see what's actually going on, how many people are getting IP addresses, how long they stay in, how long they're at one station. And that is necessary for debugging purpose. The whole stuff is anonymized, and we're seeing here one graph. We coded it 2 days ago on the 28th, and we coded it in Ruby and of course light HTTPD we used as a web server. Okay, I have to be faster. Okay, let's come to statistics. We have 1,678 associations peak and an average user count of 631. We had problems with the RX-8, so we had to change our uplink ports from one slot to the other. And of course, MRTG sucks, sorry, but the counters are not 100% clear and correct. But it's an average peak of 30 minutes. At the first to second day, 1,678. Third to fourth day, 1,423. And maximum inbound traffic on 156 megabits on the first 2 days. So what is the outlook for next year? Maybe protect our users, block interstation communication, buzz. But I don't think it will help. People can always inject packets, and a bridge filter is nothing against that. Provide 5 gigahertz cards. On the 2.4 gigahertz layer, you have no chance to make on such an event the wireless working. So if you have the possibility that buy your L100 2.11a card, use 5 gigahertz, and you will see that you get more performance out of it. Okay, so use 5 gigahertz. I want to thank especially Cookie, Hartmut Schröder, David, and Stefan. Thank you.
One more.
This one. Okay. I also would really like to thank the NOC help desk. The guys and girls sitting at the help desk were helping out the whole time, users, and giving us in the end the possibility to work on the network while trying to keep the users calm when something was wrong. So thank you very much.